this is a video recording of the first one lesson for AT Stats SS04. Today we're looking at confidence intervals, so we're taking a step further. So this is for those of you. We're looking at confidence interval for the mean of the normal distribution, where we don't know something quite important. So we're going to hopefully work out what that is. Forgive me if there are any spelling errors in this. If you want to pause and have a go at this, it'd be a good idea. I'm not going to, but this is just a normal SS02 confidence interval and, an S1 confidence interval question, actually. So pause this, have a go at it. In the next couple of pages, it's got the answers. Here are the answers. So you're basically looking for this one here. This one is your Z value, which you might not have. If you just press the button on the calculator, you end up with this one down here. And if we can make sure we round to 3 decimal places or 3 significant figures, that's fine. Commenting whether it lies within the confidence interval and whether we agree or disagree. And then the following question was talking about the fact that the weight of the sandbag or the original parent distribution is normally distributed, which is what they wanted. Second part of the question, if you've carried on, we're using standard error. So it's Z with the standard error, which means you're looking at Y bar, you're looking at the mean. So this was the original distribution that was just whatever it was, can't remember. And this is the mean of that distribution, which means you have to use standard error. And so you end up with this solution at the bottom of that one. And then this one up here for that one. This one had to be to the power of 10 because I was thinking it's everything coming out. So you needed to know what the first one was and then put it to the power of 10. But hopefully that should be okay. So the key points of a 95% confidence interval, for example, it's got up here, is we're trying to find what the true population mean is. So we've only been given a sample, and so we take our mean of our sample and we add and subtract the Z value because it's a normal distribution with our sigma over root n. Because it's a sample, we're using standard error. So the key thing that we're looking at now is that if we don't know what sigma is, it means that the actual, again pause this if you want to read this, but if you don't know what sigma is, the population standard deviation, and you've got a very small sample size, then you're not going to be very confident that your range that you're giving is going to be very good. So to be more confident that the true population mean lies within your range, you'd kind of want your range to be bigger. And to get your range bigger, where you were adding and subtracting Z lots of sigma over root n, you can change it to this T distribution. Now the T distribution, it's called the student's T distribution, and it is some homework for you to revise. But basically all the numbers are bigger because you're not as confident, because you don't believe that the standard deviation you've got from your sample can be correct. So you want to add and subtract a bigger number to make it a wider range from your sample, because it's more likely that the true population mean will lie within it. With the T distribution as well, we have a sample size is n, and we have a degree of freedom which is n minus 1, which we've used in other things, I think, but this is where we'll go to. So this is the first example. So a random sample of patients have been treated, blah blah blah. Assuming a normal distribution, which you need to have, a normal distribution that's been randomly chosen or randomly picked. That's key, those are the assumptions. Do a 90% confidence interval. So I'll just upload the calculator. Okay, I've uploaded the calculator and input all the values, as you can see, onto the calculator. So I'm after a 90% confidence interval. I don't have sigma, which means that I'm definitely looking for a T test. So this is a T distribution confidence interval. I'm going to calc, so I need to set my setup. Setup's list 1 and 1, so that's good. So I can exit back and work out what my mean and variance are. Oops, so, right, so I've got x bar is 50.71. I think it was. And sigma, which is this one here, is 35. That seems right. 35.16. That must be that. Does seem very large. Right, so we look here. This then is the t-table, so we're looking for the t-table. As you can see, depending on how many samples there are, n minus 1, so this would be a sample of 2, degrees of freedom would be 1, so 2 minus 1. This would be your 95%, because you're looking for a confidence interval, so you want 95% in the middle, which means you have 2.5% on each side. So when I use the table, I have to look up all of that. I have to look up 97.5%, which is this one here. So if I just had 2 in my sample, I would plus times here by 12.706. So I would add and subtract 12.706 times lot of my standard deviation divided by root n, which would make it very wide. As you carry on and the numbers go on, they get closer and closer to 1.96, which would be your 95% confidence interval value for a two-tailed on the Z. And actually, as the table will show, if you look at your table, when it gets to infinity right down the bottom, it is 1.96, because obviously that's what we're saying. If you've got everything, that's what you need to do. So, I think I've done all this. So, yes, that's what we agreed with our X bar and sample. Sample size is 7, so degrees of freedom is 6. You get marks for commenting on that. Using the t-test, t-tables, you can look up your t-value, shove it all in, and that's the answers you get. Okay, make sure you get those values, make sure it matches to mine. Okay, pause it, as I say, if you need to check. Comment on the hospital administrator saying it's 15. From this, we've got 24.9 to 76.5. So 15 lies below the confidence interval will be a mark, but the administrator doesn't believe. So the administrator underestimates the average time. So we're not agreeing that it's 15 minutes because it's over that. Second example, again, pause the video please. Shove in all these values into your calculator. Work out what the mean and the standard deviation is. Use the formula. The first one is assuming that the standard deviation is 0.04. So that is assuming that the population standard deviation is 0.04. If you know the population standard deviation, then you're actually using a Z-test. So this first thing here is a Z-test. With no assumption, you use the sample standard deviation you get from here, and you do the same calculation. Okay? Give an argument. I'm just going to carry on. I don't want this video to be too long, so please pause it as required. Hopefully you've worked out all your solutions. We'll go through the various things again. So you end up with that. Second part using S and a t-test. So that's a t statistic. And the sample standard deviation, you end up with that. They're very similar, which is what they commented out here. Please pause it as required. So, key point, if you're doing an estimate of the population standard deviation, it's an estimate because you don't know the population standard deviation. You're going to use S and you're going to use the T. So if you don't know the population standard deviation, it is generally a T. Unless the sample size is so big, you can invoke the S squared is a good unbiased estimator of sigma squared, which means that you can use your S squared as sigma squared, which means you know sigma squared, which means you use a Z test. Okay, that's it for this one. I'm going to do another one on the next lesson.